Download this code and get free GPT-4o from codegive.com, link in the description below. ### depth first search, DFS, in Java using stack. Depth first search, DFS, is an algorithm for traversing or searching tree or graph data structures. The algorithm starts at the root, or an arbitrary node in the case of a graph, and explores as far as possible along each branch before backtracking. In this tutorial, we will implement the DFS algorithm using an explicit stack in Java. This approach avoids the potential overflow issues associated with recursive implementations due to the call stack. ### Key concepts. 1. Graph representation. We will use an adjacency list to represent the graph. This is a common way to represent graphs in memory efficiently. 2. Stack data structure. We will use a stack to keep track of nodes that we need to explore. This allows us to explore nodes in a LIFO, last in, first out, manner, which is essential for DFS. ### Implementation steps. 1. Create a class to represent the graph. 2. Implement a method to add edges to the graph. 3. Implement the DFS method using a stack. 4. Test the implementation. ### Java code example. ### Explanation of the code. 1. Graph class. We define a graph class that contains an adjacency list represented as a map integer, list integer. The addEdge method adds an edge between two vertices in the graph. 2. DFS method. We initialize a set to keep track of visited nodes and a stack to hold nodes to be explored. We start by pushing the starting node onto the stack. We enter a loop that continues until the stack is empty. Inside the loop, we pop a vertex from the stack, check if it has been visited, and if not, we process it. In this case, we print it. We then push all its unvisited adjacent neighbors onto the stack. 3. Main method. We create an instance of the graph class and add edges to form a simple graph. Finally, we call the DFS method, starting from the vertex 0. ### Output. When you run the above program, you will see an output similar to this, which represents the order of vertices visited during DFS. ### Conclusion. This tutorial demonstrated how to implement the DFS algorithm using a stack in Java. The stack-based approach avoids recursion and is efficient for traversing trees and graphs. You can modify the graph structure and starting node to explore different scenarios.